Hi, I'm Betsy Scott with the Housing Innovation Alliance. I'm here in this beautiful modular home with the owners, Bill Spohn. And we want to talk to him today about how he made the decision to go modular, what he was looking at from a performance perspective, and how he's enjoyed living in his home, in the age of COVID.
Yes.
So you started this project. You actually just moved in here in November
That's
of
correct.
last year.
Right.
But you started the project a while ago. So what was really your motivation for the move and for looking at EcoCraft as a provider for your new home?
Sure. We were looking for a place to retire into. And it would be our first and probably our last house that we'll build.
Okay.
And we wanted something that really was close to relatives, but also with a view, with a really nice view. And then I'd say right after that, kind of the loading order was a place that was comfortable, energy efficient, and had good air quality, and also was respectful of the environment, of resources, that kind of thing. We originally thought we were going to build passive. And we looked for passive house builders, and when you Google that for Pittsburgh, at least at that time, we were seeing just like 5 companies come up, and a couple only did commercial. One was just an architect, but EcoCraft put themselves out there as being passive house certified, passive house trained, designers, etc. So we checked them out, and then in that process, we learned a lot about modular very quickly.
Okay, so that was really the performance drove the choice for modular.
Yeah, we wouldn't have thought modular otherwise. It was lucky, fortuitous.
You were already connected to the HVAC industry and to the testing equipment for home performance. So you're a bit of a super user when it comes to homeowners. So what really were your priorities? A little bit more specifically when looking at the home, both from a performance and a design standpoint.
Sure. So I've actually done some presentations on this where I talk about the influencers that drove me in this direction. So one of them is Linda Wigington. And through the late 80s, early 90s, learning about weatherization, home performance, energy efficiency, the benefits of electrification, all those kind of things. Chris Dorsey, who's out in Montana, and he introduced us to these concepts of sort of thoughtful design. Through something called A Pattern Language, a book that was written in the early 80s. Also a guy named Nate Adams. He's a big proponent of electrifying everything. And that's a way to address climate change, way to address energy efficiency. So we really took that to heart and tried to understand it. And this is an all-electric home. And I would say largely for that reason, because Nate provided us with a lot of little cases of proof that would come together to make sense there. From the standpoint of comfort, there's a guy named Robert Bean. He's on a lot of committees, worldwide committees, in terms of something called mean radiant temperature. Okay. So if the walls are warm and not sucking heat or pushing heat into your body, you're going to feel comfortable. And that's so all those elements kind of blended together led us to look at passive and then sort of like a modification of the passive concept.
We work with a lot of production home builders who are looking at going to industrialized construction, and they debate between panelized wall systems and modules, and they say one of their big concerns is often the ability to do design elements in a modular space. But this is certainly a huge design element in the home. Can you talk a little bit about how this was possible in a modular setting?
Yeah, I think it was possible because EcoCraft understands sort of the limits that you have in a factory. And they also work with a factory structural modulars, SMI, in Strattonville, Pennsylvania, who's worked with them for so long. And they also have resources for structural engineers. And in this case, the design that we wanted, the factory needed to have the assurances of a structural engineer that this could be built in this fashion. So the factory didn't shy away from it if there was this third-party stamp of approval, which we sought and achieved.
But typically the modules ship in these big, in basically big boxes, and there's this whole empty space up here. What did it look like physically when it got here to ensure that it would stay like this?
Sure. So we got a chance to visit the factory a couple times during construction, and there's it's called a marriage wall, which is sort of a double thick wall that's over your right shoulder, which is where the modules come together on both the first floor and the second floor. You can also see sort of midway up in that section, that wall section, there's another seam that goes through there that constitutes the second floor. This was all built with basically a false floor in it in the factory. So it was a rigidized box that was delivered to site.
Gotcha.
Additionally, there were 64-foot long LVL, strong as steel wood materials that were on the outside to brace it and to hold it rigidly in place. Both the first floor and the second floor were shipped that way. So they came as 4 boxes, about 14 feet wide by 64 feet long, and that's what constitutes the space of the house. Okay,
great. And then what also gives warmth in here, I think, is the combination of the floor and then these
they're Douglas fir. Beams,
the Douglas fir beams.
Yeah.
So that's both an attractive feature and also kind of reinforces the structure as well to a certain degree, right?
Yeah, that was required by the structural design. It was interesting. We had not a debate, but just a question. Do you want those beams? Do you want beams sort of like support beams, functional, not nice looking ones, buried in the wall? Or do you want us to put a bump out there? Or would you like them in the room? And we chose to put them in the room for a couple of reasons. One reason was they could be made of Douglas fir and look beautiful and blend with the floor. Second is we could put just a small air gap between them so they didn't conduct thermal energy through the wall. Otherwise, they'd be like sort of like heat fins, like radiators either in or out, and sort of disrupt what we're trying to do here with the energy.
Well, and they also blend nicely. I mean, you're out you have a beautiful wooded lot. It blends nicely, bringing a bit of the nature into the inside. So there is a way to do beautiful things architecturally with modular that there's actually a side benefit. You had to do something and it looks better probably than it would have without it. So you designed this, you figured out what your performance, what you were looking for in the home in about 2018.
Yes.
And then you just moved in here in November of last year in the middle of the pandemic. So you talked a little bit about indoor air quality and about comfort and energy efficiency and everything. How has your perception of what you had originally wanted to do changed?
Yeah, the comfort factor has been here. Once we got all the systems kind of tuned and adjusted, it's been very comfortable, not really expensive to heat. If anybody out there is familiar with like the sizing of systems for air conditioning, this house uses a 2-ton air source heat pump to condition almost 4,500 square feet. That ratio is really unheard of, and a credit to the equipment manufacturers, to EcoCraft, to the execution by the factory, et cetera, all coming together. The importance of good indoor air quality. We actually have an ERV, an energy recovery ventilator here, but we have a special one that's made in Illinois called a SERV. It's a conditioning ERV built by Build Equinox. And right around the sort of like towards the middle of the pandemic, they came out with a UV light feature that is really well engineered for their system. It works really well, like an 86% deactivation rate for the virus. So we quickly ordered one and installed it, and it's that helps to. So we're using sort of like a semi-commercial system for the air quality with the UV light, and we're following some of the ASHRAE pandemic guidelines for 800 ppm CO2 or less and UV irradiation of the air. So this is the space here is operating more or less like a commercial space in terms of pandemic related.
So, and it was fortuitous that you chose the right manufacturer to begin with to get that as an extra feature. I know that's been coming out as something that's of greater interest, becoming more common in, like you mentioned, commercial spaces and certainly moving into residential as well. When we came in here, I was struck by these. Our parent company, or founder of the Alliance, is Ibicus, and I know these look familiar to me because it was part of a Building America research project. where they worked with Detson. So how is this different, and how does this help you both with indoor air quality and comfort in the house?
So these, I guess you can call them like nozzle vents in a way. They run through 2.5-inch diameter hoses almost, so they're air hoses at a medium pressure, medium velocity. They're designed to go high wall because what they do is they create, and you can see this on the Detson website, it's great, they have these computer fluid dynamic illustrations of how the air comes out across above people and then circulates back through the room. So the air mixing and circulation and comfort is fantastic. They're also, all the ductwork's on inside walls, interior walls, to make sure that there's no heat gain or loss to the outside. So we provided sort of a tricky puzzle for EcoCraft to put together, I will say, for the HVAC. But the great thing was, like HVAC, like for a lot of typical builders, you call that trade in at a certain point. Maybe after electrical, maybe after plumbing, and they go like, now what do? We got to run air ducts. So with us, we had to have the plumbing, the electrical, the mechanical, the HVAC, all designed up front, so it had to cohabitate. And I think that was a huge benefit of it coming together fairly simply.
Well, and it was all put together in the factory as well.
Yeah, but all those decisions had to be made. Like it couldn't leave the factory without those air ducts, without the basic plumbing, without the basic electrical installed.
So it's great to see that move from what was initially a vision,
Yeah,
laying in the middle of a warehouse space, to actually being in a home in here. So that's awesome. Show us some other things from a performance perspective. Let's take a look around.
So these are, I'll walk around here. These are actually passive house rated windows. So this window is rather thick.
Oh, yeah.
So it's triple pane, argon filled, low emissivity. And it's also tuned with the solar heat gain coefficient that we wanted, which is a little bit higher, a lot higher than you'd use like in San Diego, or Phoenix or something like that. But we wanted to get solar gain, even though these are south-facing windows. We wanted to get solar gain because, again, that mean radiant temperature effect. Now, we have noticed that even in some winter days, we can have like no heat running. Just during the day, like I have an electrical monitor set up, surprise. We can see like the electrical monitor, the heat pump shut off around 10 a.m. and not run until about 6 p.m. in the middle of winter, because we get so much gain from the windows, and we do have this ERV circulating the air and the air. So, we're maintaining comfort by using the sun.
Nice.
Yeah.
So you're monitoring electrical, or are you monitoring anything else like IAQ or?
Yeah, actually. So I have like a little lab set up in the bedroom of about a dozen different IAQ monitors.
Oh, wow.
But we also have one that's installed and that's served, the conditioning ERV, because it has to know when to run. So it's a smart ERV, so it senses CO2 and it senses VOCs. So I can adjust through my app the set points for when that turns on and then for when it to turn off to achieve those levels.
You said you don't have to do a lot of heating, and we've had a very strange winter.
Yeah.
55, 60 degrees yesterday in Pittsburgh.
Yeah, but it was -2 or 2 degrees on Sunday, I think.
Yeah.
So it was, the heat pump was running, but it's a zone system, 4 different zones, so that it can adjust these different spaces, because this space gets a lot of solar, so it doesn't need a lot of heat during the day if it's a sunny day. But if it's a cloudy day or it's nighttime, it needs a lot of heat. So this space has to operate differently than other spaces in the house that are more protected. So this is the ERV, the conditioning ERV. It's made by Build Equinox in Champaign-Urbana, Illinois. It's made in a factory that's powered by solar. I have the cover off to show you what goes on inside. These are the damper controls, so it can turn the air from the inside to the outside to recirculate, control all of that. There are filters built into the top here. Yeah, so it's actually got a heat pump in it, so it can dehumidify and either heat or cool the air coming in. And it'll just sit there and recirculate the air in the house too, to actually condition that air. So it isn't just sort of accidentally taking the, or not purposefully taking the air, but it's mechanically taking the energy out of the air. So I like to think of, air conditioning is expensive air that you treat.
Right.
You should treat it well. You should kind of treasure that, the expense you put into it, the energy you put into it. So in this way, this allows us to sort of extract all that energy and all the goodness out of the air that we have. And this, to your right, is our HAC system. Now, people always say HVAC. This is V.
Right.
This is the V system.
Well, I think it's interesting too to look at the V system as big as the HA system.
Yes, it is.
And I think usually there's a short shrift for ventilation that certainly a house of this performance level, you really need to focus on ventilation.
Yeah, so this HAC system, heating and air conditioning, it's mainly, it runs off a heat pump. It does have backup electrical resistance heat if the heat pump is out of whack or fails. So that's going to do all the heating and cooling, 24,000 BTUs for this house year round. So
That's awesome.
yeah. And this is, these are the zone controls here. So I mentioned upstairs how different zones have different heating or cooling needs. So these can all be controlled. So this has a variable speed output. So it's got like a gas pedal in 8 steps to be able to deliver either as little or as much. And with heat pumps, sometimes you want to see heat pumps running all the time because they're just kind of tweaking that adjustment of the air to keep it unnoticeable and keep that mean radiant temperature up for the comfort level.
So I'd imagine the big area that you had upstairs with those gorgeous windows, that's on its own zone because that's an open space. And I think that's a challenge that a lot of people see in new housing. It
is definitely. And what's we see happening there is there's a lot of the thermal energy, of course, is rising and it's heating. There's an open updoor space, like a balcony or an overlook. We call it the lounge, that gets really warm. And that thermostat almost never calls for heat in this winter because it's seeing all the kind of the upswelling of heat. We did actually ask them to build in place the chandelier, put it in a box that could support a fan. So if we ever needed to circulate purposefully the air in that space, that could be done too. So there's these kind of like look ahead things we had to think about in some cases.
Yeah, well, that's great because like we were saying, a lot of those new homes, the system is centralized and you have this giant great room, and if the thermostat is right in the great room, then you're basing the needs of the whole house on a really unusual space.
Yeah.
So it's great to have this separated that way. I think that's so much smarter and more functional. Absolutely. Not that I'm surprised.
No, thanks.
Oh, now I see it.
Yeah, I was going to point those out too.
Yeah, that's we used to look a lot at what not to do in building construction, and you'd see the flex ducts, and they were so big, and they were kind of twisting around on each other. But this is, I would imagine, the smaller diameter helps with the velocity of the air because you don't need as much air too. Absolutely.
So these are the trunk lines for the HAC system. So these actually feed, each one independently feeds a nozzle, one of those nozzle vents. And I can show you over here, because this space is also conditioned, that's what they look like. So there's very gentle radii. They don't get pinched or kinked like some other forms of flex duct might. And they all have their own little saddles, little mounting features that are put behind the wallboard. So everything's under control. The saddles that mount them to the ductwork, and we can probably see them a little bit more clearly over here. These are screwed in, but there's a face seal on them, and they're designed for that specific duct diameter. So it really wraps nicely around and snugs right in, very tight and airtight. I haven't tested for duct tightness yet, but the average leakage is less than 5% for this system. So we're going to see at some point to check on that. So all these kind of the heating, air conditioning, and ventilation ducts were run after the fact in this space. Of course, because the modules came, everything you see at the floor joist at that level, and then they were set on top of the foundation, and then the the concrete floor was poured after that.
So then the only thing that's big is the pieces that are down here that you're branching off of. So from
The main runs, yeah.
So from a construction standpoint, when you get up to the other levels, it's much easier to manipulate that and get it into other rooms because it doesn't take as much space in the wall.
Right, so it fits very neatly within standard wall depth.
All right. Well, thank you so much for showing us around. You guys have done such an amazing job with your house, and I'd imagine you're really enjoying it right now.
Yeah.
So is there anything that you're itching to try or that you wish you would have done? I mean, you've got 500 people telling you things you could be doing in your house right now.
I think maybe some things with acoustics.
Okay.
That tends to, that really echoes in here. So maybe some surface treatments for acoustics. I wanted to throw a big tapestry down the wall, like a medieval tapestry, but she's not keen on that. So.
I think a rug, maybe.
Yeah, we don't have any rugs in here yet, so
Yeah.
there's not a lot of sound absorption going on, and you can hear it. I mean, it's and we can hear everything going on between these two spaces, hence the privacy thing that we didn't anticipate.
But that's an easy fix.
Yeah.
I mean, I think from a performance perspective, you guys have done amazingly well, and I would imagine are appreciating it a lot more now than you even knew you would before. So having been through this process and having lived in existing homes before that were built in a more of a traditional manner, what would you say to a family member or a friend or somebody who is looking to build modular? What would you tell them about the process that might be different or about what to think about in terms of design if they were to decide to go that route?
I would say be prepared to answer a lot of questions up front.
Okay.
And make decisions up front. So you have, and it's not like you're pressured, but then you control the timeline.
Right.
Right, I agree with Bill on that. You have to make a lot of decisions, which we didn't realize before you would ever think that you have to make them, because they have to do it all in the factory. So it's the very first step where they're building it in the factory, and they have to have all this stuff decided already, where everything's going to go, and that was a little difficult.
But I think there's tools that are coming out in terms of modeling, rendering, and building information systems, BIM,
Right.
which will allow you to get input from a professional very quickly about the
Right.
ramifications of your decision, and then also build a bill of materials out really quickly so you know the cost of your decision. So not there are any cost surprises for us, except putting in the septic system and building 3 wells, drilling 3 wells. Besides that, I think there are no cost surprises, really.
Right.
And one other factor, just anybody building a house, remodeling a house, living in a house, learn as much as you can to your tolerance level about how house systems work. And that way you'll be able to pick a contractor, ask questions of the contractor, and be better satisfied with the result. Put things more up front in your contract with the contractor. Know what to ask for.
Now, when we were chatting offline, you mentioned a book that was really written for the end consumer, which I think has always been a struggle as homes have become higher performance, really explaining to people, since most of this stuff is behind the walls, that's actually making it performance.
Absolutely, it's invisible, yeah.
To actually explain that. Can you share what that book is? Because I think that would be great for people to take a look at.
So it's called The Home Comfort Book.
Okay.
It's $50 on Amazon. Written by a friend of mine from Cleveland, Nate Adams.
Okay.
If you go to natethehousewhisperer.com, okay, not horse whisperer, housewhisperer.com, click on downloads. You can actually download 4 chapters for free about how a building performs, how HVAC performs, lighting, and I think the other one is bath fans. But you can get a lot of information for free to learn about how your house systems work on them yourselves, and then ask the right questions of a contractor. So I think a lot of the trends in housing innovation are going to will come more rapidly as there's a magnetism from the grassroots, from the consumer.
Yes.
So one of my goals in doing this and other things that I'm doing is to help consumers educate, to have a friendly, technically aware voice explain to them, and we living inside the theories that we think will work.
Well, thank you again, guys. Really appreciate it. It was very exciting to see your home, and looking forward to sharing this with everyone.
Thank you. Thank you
All
for
right, thanks
coming.
so much.
Appreciate it.